DateTime functions. In this lesson, we are going to discuss DateTime functions. These functions manipulate the date-time columns. Here we are going to discuss some useful SQL Server 2005 date functions, namely dateAdd, dateDiff, datePart, year, month, day, and getDate. Let's start with the dateAdd function. The dateAdd function returns a date by adding a specific number to a specified part of a date. Generally, a date has three parts. Here, DD for day, MM for month, and YY for year. Let's see the format of the dateAdd function. dateAdd, datePart, number, date field. Here, datePart would be either DD, MM, or YY. Number would be the number we want to add to the datePart. Date field would be the date field that we want to add to. For example, if we want to add 2 days to the birth date of every person in date table, we should type the query like this. Select names, add 2 days to birthday, equals dateAdd, DD to birthdate, from date table. This query produces the result by adding 2 days to their birthdays. We can also subtract 2 days from the birth date of every person in date table by adding a -2 or -2 instead of a +2 like this. Select names, add 2 days to birthday, equals dateAdd, DD -2 birthdate, from date table. This query subtracts 2 days from their birthdays on the table. Now we will see the dateDiff function. The dateDiff function returns the difference between two parts of a date. The format for the dateDiff function is dateDiff, datePart, dateField1, dateField2. Here again, datePart would be either DD, MM, or YY, and dateField1 and dateField2 would be the two date fields that you want to find the difference between. For example, if we want to see the number of months between the two fields, school date and college date, of every person in date table, the query must be written like this. Select names, months between birth date and school date, equals dateDiff, MM, birth date, school date, from date table. This query displays the months between these two dates. Now we will move on to the datePart function. The datePart function returns the specified part of the date requested. The format for the datePart function is datePart, datePart, dateField. Here too, datePart would be either DD, MM, or YY, and dateField would be the date field that you want to request the DD, MM, or YY from. If we want to see the birth year of each person, the query has to be given like this. Select names, years equals datePart, YY birthdate, from date table. This query displays the birth year of each person. Now let's move on to the year function. The year column function will extract the year from a value stored as a small datetime data type. For example, if we want to extract the year from the birth date column of every person in date table, we have to give the query like this. Select names, year, school date, as kindergarten year, from date table. This query produces the result with the birth year of each person. The month function and day function. These two functions extract the month and day from a date. Let's see this in a statement. Look at this statement. Select names, birth date, month, birth date, day, birth date, as date from date table. This statement produces the results with the month and day of the birth date for each person. And finally, we will see the getDate function. The getDate function returns the current system date and time. See this statement. Select today equals getDate. This returns the current date of the system. In this lesson, we have discussed the functions which are used with the DateTime data type. Set operators. In our previous lesson, we discussed about different types of joins. Now we'll discuss how data can be retrieved from multiple tables by using set operators. Let's start our discussion with the meaning of set. A set is a collection of objects. In relational databases, a table contains a set of rows. Elements in a set do not have to be ordered. In relational databases, rows do not have to be ordered as they are entered or stored. Set operations are used in SQL to retrieve data from multiple sets. Let's see different types briefly. In SQL Server 2005, we can use union and intersect explicitly because the minus set operation cannot be used explicitly in SQL Server 2005. The minus operation is performed by using the in predicate and its negation, not in. Let's see the general format of a set statement. Set, operator, set. Here, operator is a union, intersect, or minus, and where set is defined by a select. First, we will discuss the union operator. In SQL Server 2005, a union takes the result sets from two or more queries and returns all rows from the result sets as a single result set, removing the duplicates. In upcoming sections, we will see how a union works. Suppose we want to find the names of all the students who are from computer science and mechanical departments in the student table. We may want to write the query that uses the union set operator, like this. Let's execute this query while executing the union. SQL first executes the first part of the query, and then SQL executes the second part of the query. Finally, SQL then combines the two virtual sets of results. You can see the output as students who are in computer and mechanical departments. And now we will see the union all operation. Union all works exactly like union, but does not omit duplicates or sort the results. Union all is more efficient in execution because union all does not have to expunge the duplicates. Let's see a query with a union all operation. This query shows the results, including duplicate rows. Now we will see the in and in not predicates. SQL Server 2005 does not have the minus or difference operator. Instead of this, it does have an in predicate and its negation, the not in. This enables us to create differences. So let's see both of them. Let's start with the in predicate. Here is the query which uses an in predicate. In this query, in 1017 is called a subquery set, where 1017 is the set in which we are testing membership. So this query finds all student names from the student table where their age is in the set 1017. This query produces the output with students aged 10 and 17. Now we will see the not in predicate. The not in is opposite to the in predicate. If we use the not in our query may perform poorly. The reason is that when the not in is used, no indexing can occur. Let's see a query with the not in predicate. See this query. This query is written to select the names of the students whose age is not in 10 and 17. So this statement displays the student names whose age is not in 10 and 17.